Right. Okay, guys. So today we are gonna do the unit 2 paper, right? So I hope you all have what you call marked in the sense like mark the papers that you have done already so far in that table that I have given to you. Okay, right. So now they have sent this thing to my mail. How can I access my mail? Yeah, through this. Okay, right. Anyway, Gmail. We were supposed to be discussing that. Rumika, you have not sent me your this thing, your paper, no? Why is that? Were you did you do the paper? Hold on. I can't seem to hear. Just wait a second. Now speak. Can't you hear me? Hello. Look, I can't hear you, Rumika. Divyadarani, can you speak? Okay, there seems to be a bit of an issue. Let's record it now from now on. Okay, so let's discuss the paper. So Rumika, if you have any questions, you just let me know. So I'll be checking Divyadarani's paper. Okay, right. 14 MB. Let's see. So question number one. I'm going to start discussing right away. Question number one. Waves may spread out as they pass an object. They are saying waves may spread out as they pass an object. Uh, and then which of the following is the name of this process? Spreading out of waves. This is from definition. Okay. From the definition, you should know how to answer questions like this. Spreading out of waves when they pass through a gap or a slit. So if you don't know these things, you have to let me know. Okay. Spreading out of waves when they pass through a gap or a slit is known as diffraction. Does any one of you need a small recall? Need to recall diffraction? Divyatarani, Rumika, do you all need me to recall diffraction?
No.
You guys don't need me to recall diffraction. What about Rumika? No. Okay. Right. So diffraction, I hope you all know. Diffraction means spreading out of waves when they pass through a gap or a slit. We'll get plenty of essay questions later on, so we can discuss more related to diffraction there. Question number two: the time period of a wave decreases. Which of the following properties of wave increases? As time period of waves decreases, you should recall this equation. Look at the board. F equals 1 over t. So raise your hands if you recall this equation here. Raise your hands. Even in the meeting, those who are in the meeting also can raise your hand. Okay, great. You can put down your hands now, guys. So this is the equation that you have to use here. When time period increases, what happens to frequency? Frequency should decrease. So they are asking what increases, no? So obviously frequency can't increase. Frequency decreases. Then can you tell me what increases? Sorry. They are asking time period decreases. The other way around. My bad. Time period decreases, frequency increases. So the answer is B. Okay. That's what I was saying. Okay. Question number 3. Roman number 3. Monochromatic light is incident on a rectangular glass block. Some of the light is reflected and some of the light is refracted as shown. Incident light, refracted light. Okay. So this is a scenario that actually happens. Huh? So even though we learn about refraction, okay, even though we learned about refraction, did I use multiple colors in our last week's class? No, right? Yeah, so I might have used, I can't remember. So I bought these color pens, marker pens very recently from Pilot. So yeah, you must be able to see these nice and clear. Okay, anyway, yeah, I have like 5 colors. Today I'll be using all those colors. Anyway, this actually happens, okay? So this is known as transmission. This is what happens here. When a light ray is traveling from one medium to another medium, we know this is how we draw it, right? You should draw the incident ray initially, and then the point where the incident ray touches the boundary. Remember, guys, we should draw a normal. Normal means what is known as normal. So this perpendicular line that I have drawn perpendicular to the boundary is known as the normal. So you should remember that normal must be drawn. Normal must be drawn perpendicular to the boundary. So the definition of normal is the line drawn at right angles or perpendicular to the boundary between two media. So boundary means what separates the line that is drawn between two media. Let's think of this as water and this as air. So the light ray is traveling from water to air, let's say. You have to understand, even though it's being refracted, okay, 95% of the light that is coming is being refracted, actually 5% is being reflected, okay. So we are not really drawing it. So this is a scenario that they have drawn it actually, okay. So here they are saying which of the following properties does not decrease when the light is refracted. Does not decrease. So they have refracted the light from glass to air, no. So obviously velocity, the speed is increased, okay, the speed is increased. Frequency, you have to remember this now. Speed is a property of, so we learn about this when doing waves and when learning about light as well, okay. Without knowing this you can't get the answer here. First point that you need to know is speed is a property which only depends on the medium. So remember this, even though frequency changes, speed or velocity of a light ray, that never changes, okay. So speed only depends on the medium. You should remember these facts. Depends on the medium, nothing else, okay. Speed only depends on the medium. What about frequency? Frequency will only depend on the source producing the frequency. So for example, you imagine I am the one producing the frequency. I have a rope in my hand, I make the rope go up and down. Then what happens? I am the one producing the frequency. I alone have the ability to control that frequency. So if I increase the number of times my hand goes up and down, what will happen? If I increase the number of times, the frequency will increase, right? So then frequency only depends on the source. Frequency only depends on the source, I am saying. On the source means the source that produces the frequency, okay. Then what you should know, you should understand speed increases when going from glass to air. Frequency, we don't know what happened to frequency. Why? The source, it depends only on the source, no. So it must remain constant if the source remains constant, okay. So we don't know about wavelength. So wavelength, there's no such property. Wavelength changes based on speed and frequency, okay. Wavelength changes based on speed and frequency. So the only property that they say that does not decrease is, see, the intensity of light is anyway decreased, no. Why? It's getting divided, no. See, 95% is going, 5% is going. That this is intensity, yeah, 95% and 5%. So then obviously the only thing that can be decreased here is what? What is it? Shouldn't it be frequency? Since it only depends on the source, it is frequency. So in the question, what is happening is the other way around. Light is traveling from air to glass. So obviously the speed decreases. Wavelength depends. Wavelength also most probably might decrease. Frequency only depends on the source. Intensity anyway decreases. It's get divided into two parts, no? Right? So that's what happens. Question number 4. Question number 4. So what they say is the current in a length of uniform wire is constant. Which of the following graphs show how the potential difference across the wire varies with the length of the wire? How the potential difference across the wire varies with the length of the wire. Okay. So for this question, what is the property? What should we understand here? Let me check your answers. What are the answers that you have typed? You have not typed, in the sense you have written C. Most are saying C. Let's check Divya Tarani's paper. C. Yes. So they are saying the current is kept constant here, no? Current is kept constant here. If I is kept constant with potential difference, when length increases, what happens? what happens to the, what do you call, resistance? What happens to resistance when length increases usually? Resistance also increases, right? So then can't you understand, when length increases, since V increases, resistance should also increase proportionally as I is kept constant. Therefore, the answer should be directly proportional graph. They should increase linearly. So the answer is C here, right? Yeah, it is correct. Part 5, question number 5. So if you all have any questions related to anything that I have already discussed, the first 4 questions you have to ask me. Huh? Okay, question number 5. Yes, yes, Rumika, what is it?
So in school we haven't done electricity. So is it okay like if I don't know about things?
Oh, hold on. You actually haven't started electricity in school. So here's the thing, okay? I was planning to hold a revision session for this electricity lesson. Okay, I was supposed to tell it in our class. Janiri also to ask me, he doesn't know anything about electricity. Sorry, not electricity, unit 2. He doesn't know anything about unit 2. It's a good point that you asked me, Rumika. Okay, good thing, otherwise I would have forgotten. Janir also said he couldn't learn about electricity. He couldn't recall anything about electricity. So they want me to do a revision. So I figured if I can fix up dates that everyone is okay with, we can have the revision class for unit 2. So Rumika, you only need electricity, no? So when we are doing electricity, I'll let you know. So usually the revision means it's gonna be a very small revision, okay? You know how I teach theory, it's gonna be like a really short note, but then still you'll learn the same amount that you learn in like a normal class as well. Anyway, for a revision of the complete unit 2, it'll take us like 4 days maximum, 4 or 3 classes maximum. So the last 2 classes are gonna be for electricity, and the first 2 classes are gonna be for waves and light. So yeah, we have to. Shall I let you know the dates, Rumika? I'll post it on the group so then you can join accordingly. Try to join to the electricity part, okay? Right? So for those who don't need revision, don't have to join now. Just because they are coming to this class, you don't have to join to that class. If you want, you can join. Okay? Right. So I'll let you know after discussing with others as everyone as well. Okay. Right. Okay. Now, question number 4 is done. Question number 5. In question number 5, what happens? An electron has a de Broglie wavelength of 1.55 times 10 to the power minus 9 meters. Which of the following gives the speed in meters per second of this electron? Which of the following gives speed meters per second? Okay, so here you have to recall the de Broglie equation, right? So that is in the waves part of the lesson. So the de Broglie equation simply is lambda. The de Broglie wavelength is equal to what? H over mv. Mv means momentum. H over p or H over mv. So we are supposed to subject v, right? If we subject v, we can get the answer, can't we? So I'm going to take v here, h divided by m times lambda. So this is how you should get the answer. So you know what is h? H means the Planck's constant, right? So 6.63 times 10 to the power minus 34. What is the only answer? What is the only answer which has Planck's constant on top as the numerator? The only answer is D, right? So do you even need to look at ABC? Straight away mark D and go to the next question. Question number 6. Two waves of wavelength 12 centimeters leave a source in phase. Right, okay. So there is this small equation that you need to know here to get the answer. Rumika, can you remember that equation? There's a tricky equation, okay? I don't think you must like I don't think most students don't know this equation. Either they have been taught but they can't recall now. Rumika, can you tell me what the equation is relating phase difference and path difference? Can you recall? You guys should be able to because I taught it no before we ended the theory class. No one of you tell. What about Rumika? Rumika, do you know the equation relating phase length, phase difference and path difference? Yes or no? What about Tivya Tarani? You also don't know. Right. Okay. So I'll just tell that equation. Okay. So this is a trick that you can use for questions like this, especially questions like this. This is a trick that you can use. This is from the Cambridge syllabus. This is not really like given in the Excel syllabus. However, still you can easily get the answer there. So otherwise, so Divya Tarani, so you have marked the answer here. I can see as pi radians, right? Did you know how to get this answer as pi radians?
So I found the path difference first and then I found the phase difference.
Right. Okay. Right. So somehow there's an equation here. Okay. This is the equation that you need to use. I'll just tell it the equation first of all. Hold on. Give me 1 second. Here's the thing. Okay. So there's a funny story. It's actually, I'll tell you what the funny story is later on. Listen up, really. Hold on. Right. Okay. So first of all, I'll just tell you the equation. We'll finish the MCQs and then I'll tell you what the funny story is. This happened to me today. Okay. So the equation is phase difference equals 2 pi over lambda times path difference. Okay. This is the equation. Phase difference equals 2 pi over lambda times path difference. Some might argue this is out of the syllabus. Yes, it is not in your syllabus. But in MCQs only, mostly in MCQs, they ask these questions. In MCQs, they ask this type of questions that you are getting. Only in MCQs, they never ask it in essays. Like rarely ask it in essays, only in I think 2019 paper or something. However, so you are not supposed to give the method, no. So easily just by substituting answers, you can get the answers to this equation. Okay, so I'll show you how. They have given the wavelength is 12, right? So they have given lambda is 12 centimeters. They have given the path difference is 18, right? So then let's put the values here. So 2 pi divided by 12, okay, multiplied by 18 is equal to the phase difference, right? Is equal to delta. No, let's just keep it phase difference. So then once you solve this, what is the value that we are getting? 2, 3. We are getting 3 pi, right? We are getting 3 pi. Is there any answer called 3 pi? Just check this thing. Have we got an answer called 3 pi in the paper? No, right? There's no 3 pi. What is the value 3 pi equivalent to? Can you understand? 3 pi is equivalent to pi. That is how you should get the answer. That's it. Huh? This is how you get the answer. Just substitute it to the equation. I can show it to you in I think 2021 paper or something. In one paper also. One paper or I can't remember. It might even be the 2022 paper. They have asked a very similar question for a MCQ like this. Again, you have to use this equation here. That's it. You can easily get the answer then. Okay? Right. Question number 7. After doing this MCQs, I'll tell you what it is. Okay? Question number 7. What it is in the sense, the funny story. Okay? It's not that funny. I'll just tell it's something that happened to me. Question number 7. Two waves are coherent. What is meant by coherent? Yes, what is meant by coherent? Yes, same frequency. Okay. Now you guys don't tell. I'm gonna ask the online students. Okay, Rumika or Divya Tarani? Like for this question, Divya Tarani, answer me. Two waves are said to be coherent. If two waves are said to be coherent, one property is they should be traveling in the same frequency. What is the other property?
They should have a constant phase difference.
Yes, correct. They must have a constant phase difference. So then here, two waves are coherent. They are asking the same thing, right? See, they are asking the same thing. So at a glance, when you hear the name coherent, those two properties must come to your mind. Same frequency, constant phase difference. So the answer here is D. It's very easy to get the answer here. Okay. Here we've got the orders of maxima question. Light from a laser is incident on a diffraction grating. Diffraction grating crossing a series of maxima to be seen on screen. Oh, yeah. Maxima to be seen on screen. The position of the central maxima to the first order of maxima is shown like this. Okay. So they are asking which would change to decrease the distance. Okay. This is a very generic question. Okay. If you have seen past papers and everything, easily you will be able to get the answer at a glance without even reading. You will know the answer just as it is, and you will be able to get it. But since this is our first past paper, I'll just tell it to you. Here you should use the equation. Okay, so lambda equals d sine theta over n, right? So here you should understand d is the correct answer. D is the correct answer as decreasing the distance. D means the distance between the central maximum and the first order of maximum. It would require sine theta to be reduced. It would require sine theta to be reduced. Decreasing d would require sine theta to be reduced. So, the distance from the diffraction grating, for this to happen, the distance from the diffraction grating must remain unchanged. Okay, so the answer is D. Is that what you have taken? No. That's not what you have taken. Okay. I hope everyone got it correct, but then most of you have gotten it wrong. I'll just explain it in more detail. Okay. Hold on. I'm pretty sure you didn't get it the first time I told. That's why. If you have gotten it correct, you would have gotten, but then, yeah, most of you gotten it wrong. So here's what you need to do. I'm going to write it in the board so that you guys will get a clear understanding. First of all, you have to know d sine theta equals n lambda. D sine theta equals n lambda. This is the equation that we use for diffraction grating. D means the distance between two slits, the slit spacing. N means the order of maxima. So here n is 1, right? We only have the first order of maxima, right? Lambda means the wavelength. Sine theta means the angle to the first order of maxima. Okay, the angle to the first order of maxima. Then the separation in the question they are saying, okay, in our question they are asking light from the incident diffraction coordinate maxima to be seen against position of maxima and minima shown. Which of the following changes would decrease the distance between the central maximum and the first order of maximum? So what should be done to decrease the distance? So basically, to decrease the distance, they are proposing A, decrease the distance from the laser to diffraction grating. If we decrease the distance to the laser from diffraction grating, what will happen? It will increase, it will does not affect sine theta. So what we should do is we should decrease the sine theta angle. No? If I can decrease the sine theta value, we should be easily able to reduce the distance, right? Because sine theta is what's affecting this thing, right? Theta is what is affecting it. No? So then next, what have we got? Let's look at B, Roman number 2. Question number B. Increasing the distance from diffraction grating to the screen. So if we increase the distance, okay, so Divyadarani, you must have marked B thinking, if we take it closer, angle would get large. If we take it away, angle would get smaller. No, it's not like that. It doesn't happen like that. B is not the correct answer, as this would increase the distance between the central maxima and the first order of maximum. It will increase the distance. So they are asking what would decrease. Taking it away will increase the distance. The angle will increase then if you take it away. Okay, so that is also wrong. Then part C, using a diffraction grating with more lines per millimeter. Using a diffraction grating with more lines per millimeter. What will happen if we use more lines per millimeter? Can you understand, if I use more lines per millimeter, D will increase. D means the space between two these things, no? D means the space, not D will increase, D will decrease actually. D will decrease. D means the space between two slits, right? So D will be smaller. So as I can change this into D equals n lambda over sine theta, can you understand, if D becomes smaller, sine theta increases. If d becomes smaller, why does d become small in the first place? Because number of lines per millimeter increases. So initially imagine number of line per millimeter means initially imagine this is the diffraction grating plate. So there are like 6-7 lines here. Now what if I increase the number of lines? Can you understand the distance between two adjacent slits will decrease? So then the sin theta value will increase. We want to make sin theta smaller. So here the answer is A, B, C, all are correct. We can use light with a smaller wavelength. If I decrease lambda, can you understand, since n remains constant and d remains constant, sin theta should also decrease. Why? N is 1 always, n is the first order of maxima. So this is a 0, this is 1, n equals 0, n equals 1. So this remains 1. As lambda decreases, sin theta also decreases. Is it clear? Divyadarani, is it clear for you?
Yes.
So D is the answer. Okay, right. Question number 9. Jupiter orbits the sun as shown. The distance from the sun to Earth to sun is this much. Jupiter to sun is that much. And intensity of sun is Jupiter is okay. So this is an intensity question. Here, how do we get the answer? How do we get the answer? Power of the sun remains constant. What is the equation for intensity? I equals power over area, right? P over A. P remains constant. Can you understand? Intensity will solely depend on the cross-sectional area. So in the cross-sectional area also, this is circular, no? We have to assume this as circular, so we have to take 4 pi r squared. So can you understand, since 4 pi is also a constant, intensity is directly proportional to 1 over r squared. Okay, intensity is directly proportional to 1 over r squared. So they say intensity of Jupiter is Ij. Which of the following can be used to calculate the intensity of sunlight at Earth? So this is what you need to do. You have to build a expression for Ij using the above method I told. So in the any of the answers, have they given 4 pi? No, right? So that means this is the method that you have to use. There's one answer that they have given 4 pi. So we'll get to that, get to why that is, and whether that is even the answer, we'll see later on. However, at a glance, if you have practiced these questions, you'll understand B and D cannot be the answers. Okay, B and D cannot be the answers. Why? I just told, no. I is directly proportional to 1 over r square. This is the equation that we have to use. Okay, so 4 pi can't be like that. It should get cancelled out since it is a constant value. So we'll see what is the value for IR. So we should build the expression first of all for Ij. Ij, can you understand? Ij is directly proportional. Ij is directly proportional to 1 over, what is the value? What is the radius? 7.78 times 10 to the power 11. 7.78 times 10 to the power 11 to the power 2. Okay, this is what Ij is proportional to. So we know for a fact that B and D are not the answer. Okay, we know for a fact that B and D are not the answer. I'll tell you a trick method to get the answer first of all. Now, if you look at the remaining two answers, it is A or either C, either A or C. So then you should understand, see, if Ij directly proportional is getting a square value, this square value can't be cancelled off. Does C has a square value? No. So automatically the answer is A. But we are not sure at this stage whether the answer is A. So then we know that Ij is directly proportional to this thing. So in terms of Ij, we have to give for what do you call our IR. So we also know that IR is directly proportional to 1 over what is the value? 4.9 times 10 to the power 11 times 10 to the power 11, right? So if I were to write this in terms of Ij, can you understand? Ij will need to be divided by multiplied by 7.78 times 10 to the power 11 and divided by 4.9 times 10 to the power 11 to the power 2. Can you understand that? All you gotta do is just divide these values. Take this as 1, take this as 2, divide 1 by 2. Ij over IR is equal to, we'll take this as the equal sign, okay? We'll take this as the equal sign. This goes to the bottom, right? 1 over 2, no? Yeah. This multiplied by this, reciprocal of this. So 4.9 over times 10 to the power 11 to the power 2 over 7.78 times 10 to the power 11 to the power 2. So we need to subject IR, right? So IR is equal to IJ times 7.78 into 10 to the power 11 divided by 4.9 into 10 to the power 11, both raised to the power 2. Is this clear? You guys got this answer? Yes. What about you, Rumika? Rumika, did you get this answer?
Yeah.
Okay, great. So, how did you take the answer here? Was this how you took the answer?
I like wrote the intensity as the reason.
Okay. So, remember, yeah, good, Rumika. So, remember, in these not intensity question, in these MCQ questions, you have to understand, you must take the answer using the least writing possible. Because in MCQs, it is a commonly accepted method in the world to not use your pen when doing MCQs. Okay? Try not to use your pen or pencil when doing MCQs. Try not to, in the sense, practice. When you are practicing at home, try not to. In the exam, if there's no option, yes, please do try. Otherwise, don't come after the exam. So you told us not to touch the pen during the MCQ, so we didn't touch. We couldn't write anything. We didn't cross anything. Don't say that and come to the class again, okay? Right. Anyway, question number 10. As the temperature of the filament in a bulb decreases, the resistance of the filament changes. Which of the following is the reason for this change in resistance of the filament? So, temperature of the filament decreases, resistance of the filament changed. Temperature decreased, resistance changed. They are asking what is the possible reason. So here, you should just understand this, okay? Here the answer is A. I hope you have taken the answer as A. Yes, that is vibrations decrease. That is the reason for temperature decreases. So here's the thing. They are already giving you the answer in the question. Why? They are saying temperature decreases, no? So you don't need to understand why resistance of filament changes. You just need to get the answer which matches to the temperature decrease. So the only sensible answer is less kinetic energy, right? So that points us towards lower, that is vibrations. That is the answer. Okay, right. So here's the funny thing. Okay, here's the funny thing. It's not that funny either. So I went to my phone charger. My cable in my phone charger was not working, so I went to a store to buy this phone charger. Okay, I have it plugged in here. So it was I just went to buy this, and then they had this MacBook Pro just lying around. In the sense, I just saw a MacBook Pro. Then I was like, how much is this MacBook Pro? And then that person were like, it was a good shop. I think they had multiple MacBook Pros. Then he was like, sir, you are not gonna buy it, no? And sir, why do you ask me? He was like that, And then guess what's happened in the end? I bought the MacBook, right? And now I don't know what to do with it, guys. So this is not the MacBook that I'm using. This is my normal old laptop. Okay. Yeah, he was like, he I don't know what he must have been thinking. I was also going to buy an iPad also. My mother was there luckily. She was the one prevented me. She was waiting in the car and she had come to check why is it taking me so long to like buy the charger. That's what. I would have bought the iPad Pro also. It's a brand new MacBook. MacBook the M4 Max chip. Okay. I didn't know what I was getting into. Anyway, it was the M4 Max chip. 36 or 48 GB of RAM. Okay. 1 TB SSD. I have the MacBook here. I don't know how to work this thing. I still don't know how to like get it to shut down. See, I actually have it here. See, this is the MacBook. This is the MacBook Pro. I don't know how to get this thing working. I actually don't know how to make it sleep. So after the class, I'll set this up fully. Yeah. Crazy things, no? See, anyway, you are not there for AS class. No, when I teach AS theory, I tell you about my financial decisions is using distance and displacement. I give this example and teach students about my financial decisions. So if we have time after the class today, I'll teach you distance and displacement. In that, I'll teach you my you'll get a good idea of my financial decisions. I mean, now also you might have gotten an idea. This cost nearly 1 million, and they have this RAM storage thing as well going around in Sri Lanka. Because of that, the prices are anyway up. That dude just made a huge profit, huh? Yeah. He know exactly how to sell. I think he had this planned all along. That dude like broke his sales target today, is within this month. Anyway, doesn't matter. Okay. Right. I should probably after the class I should set it up. Yeah. Anyway, question number 11. We'll get to the essays. So today I think the class went papa. What's the time now actually? Yes, the class went pretty fast. The MCQs, we just breezed to the MCQs, no? Yeah, it's still 7:37. So we have more than good 1.5 hours to finish these MCQs. Not the MCQs, the essays. Yes. Alright, okay. So before getting on to essays, I'll give you guys 5 minutes to just go through the essays. I have to go down to the downstairs classroom for 5 minutes. I'll come back quickly. Yeah? Just wait. We'll discuss the full paper and leave the classroom. Okay? Right, just give me 5 minutes. Hold on. Okay. We'll start with question number 11. Here, we have asked part of an electrical circuit is shown in 60 seconds. 4.8 times 10 to the power 20 electrons pass point C, Z. A, show the current at C is 1.3 amperes. So yes, you have to use the equation Q equals IT to get the answer. Easily you can get the answer there, right? I mean, if you don't know how to take the answer here, you are in deep. Oh, so sorry. You couldn't hear me. Question number 11, I was saying. Question number 11, part A. You should take the answer using Q equals IT. Okay. So Rumika, did you have a problem here as well? Using the equation? Yeah, yes. So however, if you are someone who knew electricity and didn't know how to do this question, you're gonna be in deep trouble, nah? So it's fine. For those who don't know it, it's fine. But for others, yes. Well, so let's check Divya Tarani's answer. Yeah, you have taken it correctly. Then they say in 60 seconds, the resistor transfers 24 joules of energy. Calculate the potential difference across the resistor. So here, the equation that you need to use is for the second part of question number 11. You can use W equals VIT. Shall I just tell you how this equation W equals VIT is taken? So we know there's an equation for potential difference. So here's the thing. So Rumika, you just listen up. There's an equation for current called Q equals IT. Q means charge. I means current. Current is a quantity that we use to measure the electric current. It's measured in amperes. T means time, measured in seconds. C means charge, measured in a unit called coulombs. Okay, coulombs. We say it coulombs. Anyway, you have to know that. First of all, this is the equation. This equation is what you learn initially. Then you learn an equation called V equals W times Q. V equals, sorry, not W times Q. My bad. V equals W over Q. V equals W over Q. So, V means the potential difference or voltage. Sometimes we call it voltage. It's measured in volts. W means electric energy transferred. So, we measured in joules anyway. Q means charge, you know. So, it's measured in coulombs. So, you must understand something very important here. 1 volt, see, 1 volt is equal to 1 joule divided by coulomb. That means I can write it as JC minus 1. So this you have to answer. Even though joules per coulomb is a unit that we can use for, that is equivalent for potential difference, we mostly use volts as the unit for potential difference. Somehow from this equation, by combining this equation and this equation, how do we combine those two equations? So we know V equals W divided by Q. And we also know that Q is equal to IT. So instead of Q, I write IT here. W over IT is equal to V. And then I can write an expression for W as VIT. So this is how we get this equation. So Rumika, if you don't know these things, you can write it down. So this is an expression that we can write relating potential difference, current and time for the energy transferred. So if we use this equation, you can get the answer. Okay. So they say 60 seconds transfers 24 joules of energy. Calculate the potential difference. No. So they have given us the time. They have given us the energy. See, time is given, energy is given. Now you have found current as 1.3. Take everything else to the other side. W over T times I is equal to V. That's what you need to use. So simply the principle that we are using here is this: W equals or V equals W over Q. Okay. So those who want to write it down, first copy it down.
It's a part A.
Sorry, Romika. Part A. Yes, for part A, you need to know the equation Q equals IT. Okay. So they are asking you to find the current. No. Q means the charge. There's one more equation that you need to know for charge. Charge is defined as number of atoms times charge of an electron. So you know the charge of an electron and the charge of a proton are both the same. No? So mostly when we calculate charge of atoms, we multiply their atomic number by electrons, because the charge means the charge of the protons in that atom. So the charge of E here means charge of a proton or electron, which is necessarily 1.6 times 10 to the power minus 19 coulombs. N means the number of atoms. So there we can find the total charge in this manner. Q equals Ne. Then we learn about Q equals IT. So here in the question number 11 part A, Q is equal to IT. The charge they have given, see, 4.8 times 10 to the power 20 electrons pass point Z. They say point Z electron pass. So then for that part, you can use the equation total charge. You can use the equation for total charge. See, Q equals number of atoms. They say how many electrons pass? 4.8 times 10 to the power 20 electrons. No? That should be multiplied by 1.6 times 10 to the power minus 19. Then you will be able to get the total charge. That should be divided, after taking the answer, that should be divided by the time, which is 60 seconds. Remember, here time is measured in seconds always. Then we get the value I. That's it. Okay. That is the answer. Then only you'll get a value close to 1.3. So you can show it as that value is almost equal to 1.3. Okay. Right. Rumika, was it clear for you? Okay. So those who want to copy it down first of all. Damn, girl, what's your name? Okay, guys, finish up. Come on now. Copy it down, don't fool around. Yes, no, I missed this class. Hi sir, this is Pramudi. When we'll be able to have the missed class, sir? And I won't be able to class tomorrow, but is this Friday 3:30 to 5:30 okay with you, sir? I should check my timetable, guys. See, yeah. Okay, we'll see. Let's move on to question number 12. Okay, right? Question number 12 now. That is also related to current, no? A student investigated the internal resistance of a coil using a circuit shown. Okay. The student used the variable resistor to vary the reading on the ammeter. He recorded corresponding readings from the voltmeter. Okay. Alright, okay. The student plotted the graph as shown. Voltmeter and then ammeter reading. Okay. Right. Determine the EMF of the cell and the internal resistance R, simple R of the cell. Okay. So how do we get this answer here? Yeah. So they have given you the graph here, right? They have given us this graph. Um, First of all, let me check your answers. Give me your papers. Just check your answers. Give me your paper. F and R, yes. Your internal resistance is correct, but your this is how can it be wrong though? It's a very easy question, I mean. Okay, let me check Divya Dharani's paper. Okay, that's good. This is good. You have extended the what do you call this ray when current was zero. You have calculated the what do you call this thing? No, yes, your EMF is correct. It's easy, and then you should take the gradient of the graph to find the that value. No, yes. Okay, should find the internal resistance. To find the internal resistance, you should use the gradient here. However, why have you taken the answer as negative here, Divyatarani? Since the gradient is negative, is that why you took the answer as negative? Obviously, when drawing a graph like this, the gradient is negative. It's a decreasing gradient. No? However, the internal resistance don't put the negative value. Huh? Okay?
Okay.
Right? Okay. So now, your answer is correct otherwise. Okay. So I'll tell you how to get the answer here in a graph like this. So first of all, they have given this graph like half, no? They have given this graph halfway through, right? So then that means you have to understand when asked about potential difference, always we take the potential difference of the cell. Of the dry cell, we are taking the potential difference. Determine the EMF. Sorry, not the potential difference. They have specifically said the word EMF. So I'll tell you the difference between EMF, electromotive force, and the potential difference. Okay. Then you'll understand what these two things means. Okay. So Romika, for you, there are two things called electromotive force and potential difference. Okay. So I'll just tell you what those are. Most students they can get the answer correct, but then when asked specifically tell the difference between EMF and potential difference, they don't know how to. Okay, right. Tell me, guys. Okay, Divya Dharani, can you tell me what is the potential difference? What is the EMF? What do you think potential difference is? What do you feel when we say potential difference, and what do you feel when we say EMF? I need a logical answer. Okay, not the textbook definition. Oh, even that is fine if you can. What do you think, Divya Dharani?
EMF is like from the source and the voltage required.
Okay, so potential difference would mean what?
Between two points.
Yes, I understand what you're trying to say, and it is correct actually. So basically, you have to understand EMF means the voltage of the source, the power source, which is the battery. Okay, EMF means voltage across the battery. So now, when this battery is powered up and connected to, let's say, a lamp we know that across these 2 points, I'm going to mark these 2 points that I have circled as A and B. This is A and this will be B. A and B. And then the voltage, let's say the voltage of the battery is like 6 volts, for example. Then what is the voltage across A, B points? If there are no power sources or other resistances or anything across these two, what is the potential difference? The potential difference is 6 volts, right? The potential difference is 6 volts. Then what about point C and D? Point C and point D. What about the voltage across point C and D? Since there are no components across A and C and across B and D, you should understand there is no drop in voltage. So voltage across C and D will also remain the same, 6 volts. Then if I were to connect a voltmeter across this lamp, so this is the symbol that we use for a lamp, and you should remember voltmeter is something that we use to measure the voltage across components and even the power sources, and it should be connected parallel to our circuit. So then it is connected in this manner. What happens? We will get a reading of 6 volts here as well. We will get a reading of 6 volts here as well. Okay. So therefore, basically, you have to understand we are getting a voltage of 6 volts here and both these points. Anyway, the voltage across a source, in the sense, not a source, a component, an electrical component is known as the potential difference. So voltage across something like this is the potential difference, PD. Voltage across a power source. So if I were to connect a voltmeter across this power source and then measure the voltage, still I will get the 6 volts. But the difference is just the term that we are saying. We are using EMF or electromotive force here. So in this question, they are not asking us about the potential difference. If they had asked about the potential difference, we would have easily been able to write the answer. The question would have been confusing, right? Because they have given potential differences all over the place. See, like many people are calling me. I don't know why that is. I didn't answer because I'm in class. That is why I'm like being stuck for a couple of seconds. You must have heard the ringing tone in the background. I don't know why. Okay. Maybe I should answer, but now they are not calling me. Yeah, anyway. It was not the same number, it was like multiple numbers. It must be a 5 or something. Because in class, there's a habit of mine, I don't answer phones. Usually. Most of the time. Okay. So anyway, if they have said potential difference, it would have been anywhere in this V line. But they have specifically asked electromotive force. Electromotive force will mean one thing. The voltage across this power line, across this power source. Across this power source. So then what happens, guys? They have given the graph. In the graph, they have given only 2 points like this. We have to extend this point. See where it cuts. So it will probably cut around 1.5. So that is the EMF. Also, you must understand a very important point. This graph is drawn in the manner V equals EMF minus IR. This is the manner that the graph has been drawn. So, if we can calculate the gradient of this graph, we should be able to get the what? If we can calculate the gradient of this graph, we should be able to get the internal resistance. Okay? So, gradient is the internal resistance here. EMF is the y-intercept. First of all, you have to understand this and then take, like if you are taking it technically, but if you are really understanding and taking it, that this is the method that I explained is how you should take the answer, okay? Or otherwise still you can use this expression, okay? So according to this expression, y-intercept is the EMF, okay? Gradient of the graph is minus R. minus r. You might ask why the minus value. Then you have to understand, if you have done maths, in a graph like this, if it is drawn in this manner, the gradient is positive. Okay. However, if it is drawn in this manner, the gradient becomes negative. That's always. So then, even though we get a negative answer for r, you should understand minus r is the gradient. So even though we are getting a minus answer, it will be minus minus something. So that is the answer there. Okay, that's it. So once you take the gradient, you should just consider 2 points and get the gradient. You will get the answer as minus 0.75 ohms. Okay.
So how does that the current become zero? Zero
When we take EMF, no, because of this equation. Okay, so here you have to understand equation EMF is equal to V plus IR, and you might ask why the current is zero. No, the current is zero in the sense we are taking the voltage across the power source. Across the power source, you have to understand that power source in the sense it can't be divided. It can't be divided among components when taking the EMF across the power source. We EMF, instead of asking EMF, they are asking what is the voltage, what is the rated voltage of the power source. That is the reason, if you think of it logically. But then you have to understand there's a specific equation. EMF is equal to V plus IR. So in a circuit, it's like this, okay? This IR, this is the internal resistance. You have to understand, when we are given a battery like this can be written in this manner. There is a small internal resistor inside the battery. That is why in the real world, when we take batteries, when we use batteries, they heat up because of that internal resistance. So this structure, you have to take the voltage across this to take the EMF. Okay, you have to take the voltage across this, both the components, the battery and the small resistor, to take the internal resistance. So this is known as EMF. It is equal to the voltage across this V and the voltage across this small resistor. So the voltage across the small resistor, if we were to think a current I is passing, would be simple capital I times simple R, right? So that is why we take it using V plus IR. So then, since we are given this as V and this as I, the Y and X axis in that manner, I can rearrange the equation in this manner. V equals EMF minus IR. Okay, so always this is like a theory point. You learn this under theory, guys. Okay, Rumika, is it clear to you now? That is the reason why this happens. Okay. So now, moving on to the next question. The student placed an identical cell in series with the original cell in the circuit. Okay. He connected the voltmeter across both cells and repeated the new series. He plotted a new graph of this voltmeter and ammeter readings. Describe how the new graph is different from the one in this one that we have written. So can you understand, if we add a very similar new cell, what will happen to the internal resistance? Can you understand that the internal resistance will also increase or double? So if internal resistance double, can you understand the gradient also doubles? That in the sense increases. The slope would be more steeper. If the gradient increases, what will happen to the y-intercept? Our what do you call EMF, that will also double, right? So you can say internal resistance doubles, therefore gradient is doubled. Then EMF is doubled, therefore y-intercept is doubled. Or even if you write one of those points, you still get marks, huh? Okay, question number 13. Guys, I also need to clarify one thing. Were we able to complete our last week's paper? Yes, no? Yeah, I think we marked it. We put the ticks, right? Yeah, so that's good then. Okay. Question number 13 then. Moving on to question number 13. In 13th question, they have given diagram shows a ray of light traveling from a fish to an observer. The ray of light refracts at the water-air boundary. Okay. Determine the refractive index of water. Okay, it's a very easy question actually. You should take measurements from the diagram. Right. So for those who are online, I can't see your measurements. So I'm just gonna ask. I can see Tivyadharani's measurements. Can't see Rumika's measurements, but Rumika, what's the answer you got here?
The final answer is 1.34.
Correct. That should be the answer. Okay. Yeah. So make sure when taking these measurements, you use the protector correctly, and also you have to use the equation n1 sin theta 1 equals n2 sin theta 2. So that means basically n1 sin I equals n2 sin r. Always remember, most students confuse this part. N1 should be taken. Sorry, like here's the thing. I'll just draw it and explain. Most students confuse this part. Look, this is the scenario, no? So you have taken this as 42 or 43. You must have taken this as 64 or 65. So anyway, if I were to take, so this is air, this is water, we have to find water. So I'm going to consider air as N1, water as N2. Then remember, this will be theta 1, this will be theta 2. If you take, you should remember the equation is N1 sin theta 1 equals N2 sin theta 2. So whatever you took as N1, the refractive index of N1 must be multiplied by the sine of the angle theta 1 in the same medium. Both of them should be in the same medium. Remember that. So here AR refractive index is 1 also. 1 times sine 65 is equal to N2 times sine 42. Right? So that must be written. Or otherwise, if you have taken N1 as water and N2 as this thing, remember, no matter whatever this thing you take, you have to make sure the angle is corresponding. Both of them are in the same media. Okay, right. Then what happens? Part B. Diagram shows the light from sun reflecting from the water surface into the eye of the observer. Okay. Reflected light is partially polarized. Explain the difference between unpolarized and plain polarized light. Polarized light means light that is restricted in vibrating in many planes. So unpolarized light actually vibrates in multiple planes, infinite number of planes. By polarizing, we are reducing the number of planes that it can vibrate significantly. So it's like this, okay? Number of planes means something like this. Okay, can you see multiple planes in my finger? So this is one plane, this is another plane, this is another plane, this is another plane. See, multiple planes, no? A light is vibrating like this. So this here you can only see 4 planes. Like this, light is vibrating in infinite number of planes. Okay, it's vibrating in infinite number of planes. See, infinite number of planes. So therefore you have to understand, in unpolarized light they can vibrate in infinite number of planes. Polarized means they are either reduced to one single plane or a minimum number of planes. So since they say partially polarized, whatever you say is correct. Okay. So I hope your answers are also correct. Yes, multiple planes, a single plane.
So what's the third one?
What do you mean? What's the third one? The points. Okay. So here, what you must basically say is, even though they are giving how many marks? They are giving 3 marks. Yes. What you must say is, unpolarized light waves vibrate in many number of planes, while plain polarized light waves vibrate in a single plane only. And finally, you can say any single point. Okay, you can say any point which relates with point 1 and 2. Something like you can say both the light waves must travel, sorry, this is including the direction of travel, or they must be traveling perpendicular to the plane, like they are anyway transverse waves, no? If you say a property of transverse waves along with it, and then you get the third mark. Remember, it's a good question that you asked. You should say, and they propagate in perpendicular to the direction that of motion, or traveling of energy, something like that. If you, but the third point, remember, it must be common for both polarized and unpolarized light. So that's how they have given it in the marking. See, now I'm checking. See, they have say third mark dependent on either MP1 or MP2. Allow for direction of wave travel, allow for direction of energy transfer, or direction of propagation. Sorry, Romika?
So the question is different, right? They asked me.
Yeah, so the main difference is polarized light oscillate in a single plane, unpolarized light oscillate in multiple planes. You can say, even though they both of them oscillate in multiple planes, they are still traveling perpendicular to each other, or something like that. Okay, I mean, not exactly that, but you can relate to it. Okay. Is it clear? Was it clear?
Yes.
Okay, right. Now, Roman number 2, part B, Roman number 2. Reducing the intensity of the reflected light would help the observer see the fish. Explain how the observer can use a polarizing filter to reduce the intensity of the reflected light. Okay, here's the thing that you need to use, that you need to understand actually. Okay, so in a question here also, are there anyone who does photography? In photography, in these cameras, they have these polarizing filters. So when you use polarizing filters, what's the whole point? You can reduce the glare. So for example, this was a question given in one of your past papers, Edexcel, IAL past papers. You need to, most probably Jan 2022 or something. Okay. So this is the question. They say there is a photographer. They have taken a picture of a car window. The window of a car, the winds, what you get in the front, what do you call it? I can't remember. The front window. Like what you see the road out of on that window. So the car is like this. This is the window. Okay. The car is like this actually. Yeah? So the car is like this. Let's make it LC300. This is the car. Okay. Is this how LC300 looks like? Similar, no? Now they don't have this back part. No? Yeah, it's just like a box mostly. Okay. This LC300. Okay. Anyway, what happens here is, okay, this is not really LC300. Now it's like looks a bit similar. Yes, and they have these small lines on top as well. Yeah. Okay. This is the car. Imagine this car is under a tree. So then on the, what do you call the mirror here? Not the mirror, what do you call this? Windshield, no? Can't remember. We have got a glare of the tree. So basically we can see the shadow of the tree on top of the car. So we can't see anyone sitting inside it, but there are actually people, like a person sitting in the driver's seat. So this is the first image the person took from his photographing camera without the polarizing filter. Then what he did was, he used a polarizing filter. He has used a polarizing filter and then taken the image where then clearly you can see the person, there's a person inside sitting, and the glare from that tree, the reflection of that tree on top of the surface of the car was reduced, such that you could see the person actually sitting inside the vehicle. So in the exam question, they did not say LC300. LC300 is something that I put by myself now. However, you have to understand this. What has happened here is, by polarizing something, we are reducing the number of planes they vibrate. No? So that basically reduces the intensity of light, making the objects more clearer or much more easier to view without a glare basically. So in sunglasses also these polarizing filters are used. So if you are wearing sunglasses, okay, like what you can get for like cheaply 7,000, 3,000, 4,000 rupees, just check whether those sunglasses are polarized. There's a brand called Polaroid, okay, that's not what I'm talking about here. There's a brand called Polaroid also. That's not what I'm talking about. It's a sunglass brand. That's not what I'm talking about. Just check whether they are polarized. The reason is, if you are wearing a unpolarized sunglass, what happens is, when a dark filter, it's anyway dark, no, it's black in color. When we wear those sunglasses, our retina, they increase in size. They become larger, letting more light in. If you wear something like unpolarized sunglass and then walk out in the suns, UV light, there's a more chance of our retinas getting in more UV light, and it will help us, it'll make us go blind permanently. So just check whether the sunglasses that you wear are polarized. So what happens when we wear polarized sunglasses? When we wear polarized sunglasses, so sunglasses with a polarized lens, they might be of any brand, Ray brand, Gucci, Prada, right? They might be any brand, Ferrari, they have many brands, no? Dio. I haven't seen Dio sunglasses. They must have. I've seen Dio perfume though. Anyway, it doesn't matter. What you need to understand is, if you are wearing a polarized sunglass, what would happen? Even though our retina increase in size because of the darkness, no UV light or lights vibrating in many planes will come to our eye. Okay? So they are saying, explain how the observer can use a polarizing filter to reduce the intensity of the reflected light. So the model answer here is, polarizing filter. What will happen? It will filter most of the light that is coming, and then so you must also state something about either vertical or horizontal polarization here. So you must say, if we can place a vertical or a horizontal polarizing filter, horizontally polarized light is not coming, only vertical light will be coming. So you must say either that. Okay, so if you say, if we can place a horizontally polarizing filter, you should say, then vertically polarized light will not be able to come through, only horizontally polarized light will come through. Or else, if you say, if we can keep a horizontally polarized light wave or vertically polarized light wave, you'll understand, no, the other type of light waves won't be able to come towards us. Okay, so yeah, that's it. I mean, there was a MCQ question as well in 2022 Gen paper, I think 2021 Gen paper, related to this polarizing light waves coming through two polarizing lenses. Okay, so these questions, if you know these questions, yes, they are past papers. So Divya Tarani reduced the intensity of light observed. We explain how the observer can use a polarizing filter to reduce the intensity of this reflected light. Yes. Rotate the filter so that it is about 45 degrees with the reflected weight. This decreases the intensity. Yes, you can rotate the filter. I've actually got some filters downstairs. So if you rotate it 45 degrees, yes, you'll everything that you'll see will be darker. Don't say 45 degrees, Divyatarani. It's not 45 degrees. Make it 90 degrees. Why did you say 45 degrees? Did you meant keeping a horizontal filter and a vertical filter together and then crossing them?
Yes.
Right, okay. So you must mean that, you must say that. Keep either a vertical filter and then make the other one horizontal. That's it. So then only one type of light rays will be able to pass through. Okay. Right. Now question number 14, they have this star mark. Question number 14 is a star marked question. So let's see what they are asking here. In question number 14, they are simply saying, um, they are simply saying, the circuit shown contains a fixed resistor and a LDR. Explain why the power dissipated by the whole circuit changes as the intensity of light incident on the LDR decreases. Okay, so you should refer to the resistance of an LDR changes as light intensity increases. Refer to why the resistance of LDR changes as the light intensity increases. Okay, so I need to check your answers that you have written here so far. Okay, right. Let's check with those in physical class. Hold on. Mm. Let me check. Oh. No. Here you'll get 3 marks. Four marks. Let's check yours. Okay. Divyadarani's paper I'll check after we are done explaining. So here, this is what you need to finally say. Okay, this idea should be there in your question. So remember, this is a 6-mark question again. And if you really think about it, if you look at the question closely, you'll understand there's a star mark here, right? The question has a star mark. So what does this mean? You have to read what they have given to you. You have to use what they have given to you in the question, and also think a little bit out of the box. But in this question, actually, you don't have to think a little bit out of the box unless for the last part. No, let's see. So here in the question, they are saying basically, explain why the power dissipated by the whole circuit changes as intensity of the light incident on the LDR increases. So the power dissipated changes of the whole circuit as intensity of the light incident on LDR increases. What will happen? So you must say first of all, what will happen to the LDR when we increase the intensity of light? As light intensity increases, you must say the resistance of LDR decreases, because more charge carriers, or you don't need to really say that. Oh yes, or more charge carriers are passed. So what Divyatarani has written is, as light intensity of the light LDR is increasing, its resistance decreases. Since current is constant in series circuit according to V equals IR, V is proportional to R. So voltage of current circuit increases. What? Resistance decreases. Okay, so you have said here resistance decrease, and why you are saying voltage of the current increases? Why if resistance decreases, voltage also should decrease, no? Then power dissipated of the whole circuit increases due to P equals IP. What's that? Divyadarani?
So voltage will decrease. Yeah.
Yeah, if voltage decreases, then you are basically saying this will also decrease. The power dissipated will decrease, no, you are saying. So everything after that is wrong, no? You have written, you might, because here in this question, you might not get error carried forward. There are some questions that they give marks for error carried forward, but then in this question, you won't get marks because of that. Okay, you will get like, for the first part is correct, no? As resistance of LDR decreases, as the intensity of light incident on the LDR increases, its resistance decreases. For writing that, you will get 1 mark. Also, the reason this happens is because of increase in the number of conduction electrons. So when resistance decreases, what happens? More current will be passing. So you can even use the equation P equals IV. What you have used is correct, Divyadarani, but you lost marks due to a very silly mistake. Okay, so you got only like 1 mark. That's the reason. So as long as you have these points, resistance of LDR decreases. This is due to the number of conduction of electrons. Number of conduction electrons increase. That means basically the current passing increases as R decreases. Why? The voltage remains the same. No? That is the reason this happens. So voltage directly proportional to R, that is also wrong. Huh? Okay, Divyadan, you can't use that. Why? Have they said anything about changing the potential difference? No, right? So you can't say voltage increases, voltage changes. Current changes in a circuit. Yeah. Say what happens?
So, but in the series circuit, the voltage gets divided. No?
Yeah, the voltage gets divided, but they are asking for across the whole circuit why the power dissipated increases, right? Explain why the power dissipated by the whole circuit changes. And see, you have not read the question properly even. These are like very common mistakes. This can even happen in the exam. Huh? This is nothing to be worried about. It is a very common mistake students make, not reading the question properly. See, this is what happens. Huh? In the exam, if this happens, see, whole 5 marks gone. You will get 1 mark for writing this. This is correct. So out of 80, calculate how much of a percentage is 5 marks. So 5 divided by 80 multiplied by 100. How much is it? It's not that much, 6.25 marks, but that's how it adds on, right? As a percentage, see. Anyway, what you should say here is, first of all, you must state resistance of LDR decreases. Then what happens? The current passing through the circuit will increase because potential difference is kept constant. They are not changing the potential difference. No. When current passing increases, what will happen? We can use the equation P equals VI. From the equation P equals VI for the whole circuit, since V is kept the same, I increases, the power dissipated by the circuit increases. Okay? However, they are asking, that's not the end of it. Okay? You should refer to why the resistance of the LDR changes as light intensity is increased. That you must say, that is not really in your syllabus. So you have to think of something. So what all you know is when resistance of the LDR changes, in the sense the resistance decreasing. No? When the resistance is decreasing, the current of the whole circuit is increasing. So you must give a reason to why current in the whole circuit increases. In the sense, what happens in the circuit when the current is increasing? What will happen? So what you should say will happen? You must say increase in the number of conduction electrons. Now the number of conduction electrons carrying the conduction electrons are what they are carrying current. No? So you must say more charge carriers are produced or the number of conduction electrons are increased. That's it. This will decrease the resistance of the circuit, causing the current to increase. Since the supply of voltage is kept constant, total power dissipated by the circuit increases because of the equation P equals VI. Okay, that's it. Or even you can use any other equation. You can even use P equals V squared over Ry. Resistance decreases, no, anyway power increases. Okay. Or even P equals I squared R. Why? Even if you use P equals I squared R, I is squared, no? So I increases by power 2. Resistance decreases, it's just I squared R. So even if R decreases, I is increased by to the power 2. So even if you have written any of those above equations, you will get full marks. So Rumika, you might not understand this question like completely. Don't worry about it. Once we do this theory parts, you should be able to understand it. Okay. Right. Tivetarani, was it clear for you?
Yes, sir.
Okay, great. Now next point, they are saying ultrasound can be used to check for cracks in metal beams. Okay, transducer emits a pulse of ultrasound into a metal beam. The same transducer detects the returning pulses. Part of the metal beam is shown. The beam contains 3 cracks A, B and C. So crack A, crack B, crack C. The transducer detects a returning pulse from each crack. Explain why there is a returning pulse from crack P. Okay. Right. So for a question like this, what you should say? They are asking, explain why there is a returning pulse from crack B. So they are not asking about the what you call metal. They are not asking about anything. They are saying ultrasound can be used to check cracks in metal beams. This emits an ultrasound into a metal beam. It detects the returning pulse. The part of the metal beam containing the three cracks have been shown here, and you are asked why there is a return impulse from crack B. So what you can say? You can say that some of the pulse passes through crack A and goes towards crack B, and from crack B it gets refracted. Why is that? Why does it get refracted? Because the density, or you can say even the, what do you call, when there's a crack in the middle of a metal, it's different to the composition of the metal. So then once you send an ultrasound wave, there's a higher probability of it getting reflected back towards the transducer. Okay, so as you have, long as you have said something like that, you get the full 3 marks. Okay, it doesn't need to be 3 points here. So if I will check the answers, uh, yes, some of the pulses that refracted through A refracts from B and returns to the transmitter. Yes, yes, that is enough for that question. Part B, they are saying one pulse returns 1.4 times 10 to the power 5 seconds after being emitted by the transducer. Deduce whether the pulse has returned from crack A, crack B, or crack C. You should take measurements from the diagram. Okay. So here, basically all you have to do is use the equation distance equals speed, speed equals distance over time. They have given us the speed of ultrasound waves. They have given us the speed. Okay. They have given us the speed. They have given us the time. So using these two things, we can multiply the time by speed and get the distance, right? And then if we can measure the distance from the topmost point to the ultrasound point, okay, and then divide it by 2, and then multiply it by 2, you can get the answer which is closest to the distance, the actual distance, right? Was it clear? Romika, is it clear what has happened here? Yes, right? So basically you should get the answer as crack A. Because when you use the speed equals distance over time equation here, the answer that you are getting is for the ultrasound wave to go hit the crack and come back. So it's actually twice the actual distance. So all you need to do is the distance that you are getting, it will be like 0.04 something. That should be divided by 2. Not 0.04 something, it should be 0.4 something. That should be divided by 2 and measured. And then only you take measurings from the transducer, and then the only measuring that satisfies it is crack A, right? So that's the answer there. Question number 5, part C. Explain why ultrasound used to crack metal beams usually have frequencies of megahertz. You have to say something about detail here. Higher frequency means lower wavelength. Since the wavelengths are short, we can get ultrasound waves which contains more details. So it hits faster, no, then it hits faster and it gets reflected fast as well. So we can get more detailed, a greater level of detail. Okay, so you must state that. You must say we are using a higher frequency because then wavelength will be much shorter and we'll be able to get a greater level of detail here. That is the reason. Okay, right. Question number 16. Okay, how many questions are here actually? 18, 16, 17, 18. So we are actually on track to finish a paper, no, today. So here's the thing, guys. Next week we can actually try to do more than one paper, try to discuss more than one paper in this May June section. We can try to discuss more than one paper. Okay. Okay. Now it's 8:34 still. Yeah, we should have time to finish these questions. And yes. So next day I'll let you know what the papers that you have to do. Question number 16, we'll quickly do these questions and talk about our plan for the next week. Question number 16, drivers use car headlights to emit light in dark conditions. The graph shows how current I varies with potential difference V for a car headlight. You can still hear me through the mic, no? Yes. Okay. Current varies with potential difference. So y-axis they've given current, x-axis they've given potential difference. Headlight will emit light when it dissipates at least 35 watts of power. 35 watts of power. 35 means what? 7 times 5. 9 times 3.8. Okay. Determine the minimum potential difference for which the headlight will emit light. So, Tivedarani, and now only I show you answer here. For part C, just writing more precise is not correct. Nah? So, do you even know the meaning of precision and accuracy? Precision and accuracy? Do you know the difference? Someone tell me. Let's say no. You guys don't tell. No. Yeah. You don't tell. Let's ask from an online student. What about? Okay, Rumika, can you tell me the difference between precision and accuracy?
Accuracy is how close, like a specific data value is to the real value. Precision is how close each, like a set of values are close to each other.
Did I teach this in class? This class? No, right?
No, it's cool.
Right. That's good. That is actually what I needed to hear. Stivedharani, you also need to understand precision means values are closer to each other, not the actual value. We don't know whether they are close to actual value or not. It's just that the measurements are just closer to each other. Accurate means they are close to the actual value. So we don't use these words. We mostly use this word in those two words in lesson number 3 and lesson number 6. When doing papers, you'll understand. I'll teach it to you. However, you can't just say more precise, huh? So correct it. Question number 16. This is the graph. Yeah, this is the graph. How do we find the answer here? You have to find the corresponding values from this line given. Okay, you have to find the corresponding value. So that was what I was looking initially. That's why I said like 9 and 3.9. That is the reason. So I'm gonna share the screen and show it to you why that is. Just hold on, I need to download the paper. Downloads. Your download is being scanned, McAfee. Why isn't it opening? They are still scanning it. Okay. Now, let me take on the question and share the screen. Okay. In a question like this, you have to use the equation P equals VI, and since they are saying like almost, this is what they're saying, when it dissipates at least 35 watts of power. No? So here you have to find the corresponding voltage value. Okay, corresponding voltage and current value which gives 35 watts in this graph. So I have found it out as these two values. This is 3.9. What you are getting here? It's just right here. Okay, it's just right here. This value is 3.9. Oh no, 3.9. Okay, this is the value. This is the line. I have gone like one part behind it, below it. This is the line 3.9. So you have to find it using this best fit curve. This is a best fit. Almost you can see this as a best fit curve. You have to find it using this best fit curve, and then right here show that we have, according to P equals VI from the best fit curve, the current will be 3.9 amperes when the voltage is 9 volts. So the maximum potential difference is 9 volts. That's all you need to say. Okay. So then that's it there. That is how you should take the answer there. Okay, guys. And show that 9 times 3.9 is 35.1 watts. That's it. Question number 16, part B. So Divyatarani, get that answer correct. Question number 16, part B. In a car, two headlights parallel with a 12 volts battery. The battery has negligible inter resistance. Explains the advantage of connecting the headlights parallel with the battery rather than in series. What is the disadvantage of series connections? In housing also, so you will learn this. I mean, you don't need to really learn it. You must have already learned it in O levels. Okay. Anyway, when you are doing this electrical and electronic engineering, you'll understand if you are to do. That's what I've done. You'll understand in houses, when you wire these houses, we most of the time we use parallel lights. So we have to create this using circuits. The house was main circuit. Even though you like the main breakers, if you just tinker with them, you'll realize the whole house is connected separately. That's why in your circuit breaker, you don't call it like the main switch, mains board. Uh, they are like separated. They have separated the small stuff things, and they have got separate switches that you can tip up and down, make it go up and down. And once you make the switch go up or down, only a certain part of the house will not have current. So I used to do it when I was like okay, during COVID and during the power cut especially, I used to do it. So my sister was studying anyway. Okay, she recently did her A levels. She finished her A levels IAL. Okay, so when she was studying, there were anyway power cuts going on, like massive power cuts, like whole days the power was not there. So on the days that the power was there, what I used to do was I used to close the switch here only to my sister's room, and then I would say, there's a power cut, and then she'll be without power like the whole time till parents come. Yeah, she actually didn't got to know it. I used to like, I put it on temporarily and then switch it off and then put it on. So you couldn't charge your laptop or anything. Yeah, it was fun. It was fun. Actually, it's not good to do. Don't try this at home. But then you can actually do stuff like that. And then one day I got angry with our whole house, and then I switched off the whole circuit for the whole house, and then kept one on for my room. And then I was in my room the whole time, and they thought there was no power. Right? It's a good thing, huh? It's a good trick. So when everyone is not there in your house, you can try this out actually. Okay. When I say when everyone is not there, there's a huge chance that if you are electrocuted, no one will be there to save you. Okay, so do it with your own risk. You can just check. Okay, just wear something like rubber slippers and do it, just for caution. Okay, you can just check what are the circuits that switch off, what are the rooms that don't have power when you switch one on and off, and then you can get to know exactly, if you do this for like a couple of times, if you do that 3 or 4 times, you'll get to know exactly which switch handles what room. So anyway, what I wanted to say was, when you connect something parallelly, you can separate it completely. So if one headlight was to go out, like short circuit or something, the other headlight will still work. So that is why in cars, we don't usually see the headlights. But when we are going behind them, sometimes one of the tail lights are not working, no, and that is the reason. It might have shorted, or the car must have gotten into an accident and the tail light must have broken, one of the tail lights, but the other one still lights up. That is the reason. So in parallel, you must say one of those reasons. So here, since they are giving 3 marks, you have to elaborate it further. And they have also given us a value, right? They are connected parallelly with a 12 volts battery. Explain the advantage of connecting the headline parallel with the battery rather than series. So you can even say the voltage. So if we connect a battery in series, what will happen? Each shot will only receive a voltage of 6 volts, right? However, if you connect the 2 headlights parallelly, both of them will receive 12 volts. Next, what can happen? In parallel headlights, they will have a higher brightness. However, in series, the brightness gets divided into 2, right? Next, what happens? In parallel circuits, if one of the headlights breaks, like I told you, the other will still keep on, because why? If one headlight breaks, the other will not break, because they are connected separately. Okay, so then all the current traveling which used to travel in the other circuit will come back, will not travel there anymore. Okay, that's it. Right here, in part 2, Roman number 2, before going to Roman number 2, you should check if the headlight breaks, if the same power across both. Yeah, can be switched on and off individually. That is also true. Yeah, Tivedarani, what you have written can be switched on and off individually. That is also true. Okay, but why have not done the part 2? A student writes the following statement. When connected to a 12-volt battery, the combined resistance of two headlights in parallel is 1/4 of the combined resistance of two headlights in series. Yeah, deduce whether this is correct. You should answer should be taken from calculation using data in the graph. Okay. So here it's the deduction. You just have to show something using the graph. Okay. So here for this question, you have to use only the only equation. Okay, the only equation that you have to use is V equals IR. There's no other equation that you have to use other than V equals IR. So there's the student statement. When connected to a 12-volt battery, the combined resistance of two headlights in parallel is 1/4 of the combined resistance of two headlights in series. It is not 1/4 actually. Okay, so 1/4. So we have to show that just saying it is not enough. We have to show that using calculations from the graph. So if you look at the graph, what they have is how current varies with potential difference for a car headlight. For a car headlight. So here, all you gotta do is you should first of all find the resistance of a single headlight in parallel. We have to use data from the graph for this question. Okay, so that means you just need to just divide voltage by current. That's it. So let's take a voltage and divide it by current using the graph. There should be the corresponding current. So what is the voltage? Let's take the furthermost point. Okay, I'm going to share the screen. No need to share the screen now. You need to take 12 volts, and I'm going to take what's the furthermost point here? 12 volts and 4.6, right? Okay. So if I divide 12 volts, if I divide it by 4.6, what is the current that I'm getting? Let me check. Two 2.608. So let's take it as 2.6 ohms. This is the resistance of one headlight, right? So then all we need to do is we have to imagine. So that's what the student is saying. We have to imagine at 12 volts. So the reason I took 12 volts is because the student said so. See, in the example that he is saying, when connected to a 12-volt battery, he is saying. So we have to relate. So basically, if I were to take it in a drawing, you have to imagine the whole voltage connectors is 12 volts. This is 2.6 and this is 2.6. So you have to get the combined resistance. 1 over RT equals 1 over 2.6 plus 1 over 2.6. Let's first of all calculate what is 1 over 2.6, and then if we multiply by 2, we'll still get the same answer, right? 1 divided by 2.6 multiplied by 2. So here we get 1 over RT equals 0.769. So what is this 0.769? 0.769, I can take a 0.77. That is 1 over RT. So if I want RT, 1 divided by 0.77, I get the answer as 1.29. So we'll take it as 1.3 ohms. So the equivalent resistance of this scenario is how much? 1.3 ohms. Okay. Then next we'll take for a single headlight. For a single headlight connected in series, so we know if we connect two parallel headlights at 12 volts, the voltage will be the same, right? But if we connect two series headlights like this, what will be the voltage across each one? 6 volts, right? So they should be connected to a parallel circuit, not a parallel circuit, the same voltage, 12 volts. Here they are connected to a 12 volt circuit. So here 6 volts each. Look at the graph, find the value for 6 volts. What is the value for 6 volts? What is the current that they are giving? At 6 volts, see, they have marked it as well. So if you were to look at it, what's the point that they have marked? 3.2, right? So what should we do here? We should divide 6 by 3.2. Again, in this scenario, 6 is divided by 3.2 from v equals I. V of I equals 6 over 3.2. So what is the value that we are getting when we divide 6 over 3.2? 6. 1.875. So 1.875 ohms. We'll take it as 1.88 ohms. 1.88 ohms. Since there are two of them, so this is for one, right? Since there are two of them, what is the total one? RT equals 1.88 times 2. 1.88, 1.88. So 1.88 multiplied by 2, what is the answer that we are getting? I'm sorry, 3.76, right? 3.76 ohms. So, what is the difference? Sorry, not what is the difference. So, in the statement, the student has said, when connected to this one, quart of a combined resistance of two resistors in series. So, all you need to do is divide 3.76 by 1.3. 3.76 divided by 1.3. What is the answer that we'll get? Something close to 3. 3.76 divided by 1.3. We will get 2.89 or 2.9. So it is only 2.9 times, right? So it's not 4 times, no? Therefore, you can say, so therefore it is 2.9 times less. 2.9 times. The resistance is 2.9 times less in parallel, not 4 times less. Is it clear? This is how we should take the answer. If it is not clear, I'll give you the exact way of writing this, like with a drawing and everything. So all you gotta do, even if you draw the diagrams, you'll still get full marks. Somehow you need to get the answer here. They're only giving 3 marks though. It is better not to draw the diagrams here, in the sense, even if you draw, they won't cut marks, like it'll take up more time. Divyatarani, is it clear for you? Hello? Is it clear? Can't hear. Romika, can you hear me?
Yes, sir.
For you it is clear, no? Okay. So now, yeah, those who want to copy this down, copy it down. Oh, it's 8:51 now. 52. Yo, the time went way too fast, no? Sometimes for some questions this happens. So after this we have question number 17, which is again, see, 14 marks. And question number 18, which is again 12 marks. See, this is the reality of the last couple of questions. When you come to the last questions, they have made these questions like very super long. This is the 2023 paper. No? If you look at 2025 or 2026 paper, this effect of the last questions being extremely long, that is like a lot more controlled. So in 2023, it actually went out of control. See, in the first couple of questions, only you get 6, 7, 8 marks, like small amount of marks. And in the last questions, 12 marks, 14 marks, and again 12 marks. So those who want to copy it down, first of all, copy this down. And then, so today we'll finish this question number 16. And then, so next day, remind me to start from question number 17. I'm going to put a note in our class, okay, in the class group. I'm just going to put a voice recording, a voice message saying that is where I stopped, okay. So then next day when I check back in to send the message, I'll know exactly where we stopped. So I'm just going to put the recording now. Okay. So I'm going to say, hold on. So for the next week's class, so no, that is not going to work. In today's class, we stopped at 2023 unit 2 paper, May June paper, question number 16 we finished. We have to start from question number 17. So next week when you come, get the 2021 May unit 2 paper done along with 2025 May unit 1 paper done. Was it clear, guys? So I'm anyway going to discuss question number 16. So while those who are writing this part, I'll just tell you what are the papers that you have to get done before when you're coming to the class next week. When you're coming next week, get the 2021 May June paper done. Okay, 2021 May June paper for unit 2. Then 2025 May June paper for unit 1. That means the last year's paper. So just to confirm, did we finish? So what are the papers that we have already done in this class for unit 1? We have completed 2022, we have completed 2024, and we have done now today we are almost done with unit 2 2023 paper. No? So in unit 1 we've done 2 papers. So this will be the third May June paper under unit 1 that I'll be teaching you. So then in my part, if you think about my part, since I said it will only be discussing I'll be discussing each and every question of all the May June papers. That is now complete in my part. Okay, so you guys have to focus on Feb and October papers. So I'll be giving random questions in the class itself for you guys to do from those papers. Okay, so just make sure to copy this down. 2021 May June unit 2, 2025 May June unit 1. So when you're coming the next day, get those papers done. Sometimes I might not be able to even finish one of these papers, but then still as long as you have got it done, we can quickly discuss them. So next week, within the first 15 minutes, we have to finish this paper. So first of all, the first thing we have to start with question number 17, which is the atomic line spectra. So for those who have doubts related to atomic line spectra, I'll be clearing them. Anyway, so this is over now. Shall I erase this? Yes. Divya Tarani, shall I erase this, what I have written in the board? Here, this part. Did you? Okay. Okay. Now, next. Right, okay. In part C, headlights are connected in the circuit using the copper wire. Current in the wire is 4.6 amperes. Calculate the drift velocity. Okay, so here you have this is an abbreviation. You have to remember the equation to get the answer here is I equals A N VQ at a glance while reading the first 2 sentences, like I did. Okay, so the abbreviation for this equation is very important. Okay, the abbreviation is, for you to easily remember, I am not very quiet, which is true for me because I am actually not very quiet. Nah? People who know me know that I am not very quiet. Anyway, this is the abbreviation. Even if you are very quiet, doesn't matter. Just remember this abbreviation. I am not very quiet. I equals ANVQ. This is the equation that you have to use. So you are asked to calculate the drift velocity. No, that means you are asked to calculate V. So subject V in this question, you will get the answer. If you subject V, you should get the answer here. Okay. Okay. Right. So then, guys, let's check your answers. You have gotten these answers. Let's check Divya Dharani's first. Interesting. Are you sure this is correct, Divya Dharani? This answer is not correct, Nomin.
Sir, I didn't learn that equation in school yet, so I took it from the textbook.
Okay. However, before using this I equals A and VQ equation, there is one more that you need to do. You have to find the area. So how do you get the area? Use the equation R equals rho L over A. Unfortunately, there is no abbreviation that I have made up for this. Okay. So anyway, you should need to remember this. We subject A here. We subject what is A. So then rho L is divided by R. Okay. So they have given what is rho, right? Rho means the resistivity. Resistivity of copper as 1.72 times 10 to the power minus 8 ohm meters. So I'll just do this question with you guys just for the sake of it. What is the rho? 1.72. 10 to the power minus 8 ohm meters. Okay. That should be multiplied by the length. They have given resistance per length, no? They have given us resistance per length. So what does resistance per length means? Resistance per length means R divided by L, right? So they have given us what is R divided by L. See, resistance per length. That is 1.75 in 10 to the power minus 2. So here we know it is rho L over R. L over R. So if R over L is this, can you understand? L over R is 1 over 1.75 times 10 to the power minus 2. 1 divided by 1.75 times 10 to the power minus 2. Therefore, what happens? We can straight away divide this by 1.75 times 10 to the power minus 2, right? Is there anyone who couldn't get the answer? Who couldn't get this? No one in physical class. What about Divya Tharani and Rumika? Did you all guys got what happened here? Why R over L becomes this and how L over R is this? Yes. Okay, right. So Rumika, just don't stress about it yet. Okay. So you'll get this basically. All I need you to do right now is just write these things down. Huh? Okay. Anyway, once you solve this, you should get what is A. You should get a value for A. So let's solve it. 10 to the power minus 2 cancels out. 10 to the power minus 6 it becomes. So you should get the answer as 90. 0.98. Yes, so it will be 9.83 times 10 to the power minus 7. This is your area, meter squared. Then we use it in this equation, I equals ANVQ. So all we need to do is subject V. So I will be divided, I is the current, I will be divided by ANQ. N means the number of charge carriers. What is I? I they have given 4.6 amperes. 4.6, not 6.4, 4.6 amperes divided by, we know what is this A, 9.83 times 10 to the power minus 7. We also know what is N, since they have given it, number of charge carriers per cubic meter. What is it? 8.49 10 to the power 28. Times, what is Q? Q means charge of an electron. So they are asking for velocity of electrons, no? So therefore we should multiply by 1.6 times 10 to the power minus 19 coulombs. Once you solve this, you will get the velocity of, or the drift velocity of these electrons as what? 3.4 times 10 to the power minus 4 ms minus 1. Okay. So Divyatarani, are you familiar with this equation for resistivity? R equals rho L over A. So this was converted to this actually. Yeah. Yes or no? I couldn't quite hear it.
No, sir, we didn't learn that.
You have not learned this equation. Okay. So there's this term called resistivity. Yeah, Romika?
What's Q?
Q means the charge of an electron here. Quiet means the sense electron. The charge of an electrons. Okay. Simple Q. The reason we use simple Q is to depict charge of electron. In some books, they have given it as simple E. Okay. Same thing still. Anyway, there is a quantity called resistivity. It is depicted by the symbol rho. Okay. So rho L over A, we can define an equation relating R, the resistance, the length, area and resistivity. This is that equation. Okay, it's just an equation that you need to remember and know. That's it. I mean, anyway, you are given all of these equations in your equation booklet that you are getting in the exam. Okay, so that's it. Those who got it wrong, just copy this down. So after this week, in the sense, in the beginning of the March, in the first week of March, we'll start unit 3 papers. In the sense, doing like 4 to 5 unit 3 papers is actually enough for you all. You don't need to do any more papers. But before teaching you, before discussing unit 3 papers with you, I'll take 2 days, 2 to 1 days, okay, and teach you everything that you need to know related to unit 3, especially the uncertainty part. That's where most of the marks are concentrated. Okay, so I will be doing that in the first week of March as well. Anyway, that is it for today. Okay, guys. So if you have copied this down, you can leave. Make sure when you are coming next week, 2021 May June Unit 2 and 2025 May June Unit 1 papers must be completed. Okay. Right. So online students, Divyatarani and Romika, do you have any questions related to what we did in today's class?
No.
No, right? Okay. So that's good. That's good. That's great. So when you're coming next week, just make sure to get those papers done. I've sent an image of the papers as well to the group. That's it. Okay, guys. So that's it. You can leave the meeting now. Goodbye. Then after copying this down, you can leave. Okay. Thank you. Good night.